Hi folks, how's it going? Welcome to another Carbide Office Hours. I think this is episode 13. We've been going on for quite some time now. Happy Friday, all of you. For this episode, I wanted to go over some really basic troubleshooting things that you can do if you run into any issues, because a lot of the times, if you run into an issue, it should be pretty simple to fix. But if you've only just built the machine or you don't have a really strong understanding of how the CNC drivetrain works, it can be a little challenging to work backwards to figure out what's wrong. So today I wanted to just go over just how the machine fundamentally works and how you can work backwards to figure out what's not working, or to try and isolate the problem so that you can tell support what you think is wrong and help them get to the root of the problem faster. Let me know if my audio is no good, but I'm going to jump over the machine and I'm going to walk you through some common issues or problems or mistakes if you don't set up the machine correctly. So let's transition over to the main camera. Okay, so machine, Shapeoko. First of all, one of the most common things that'll happen, or I wouldn't say most common, but one of the first issues you could run into when you're trying to get up and running with the machine is that one of your axes doesn't move as it should. So let's say you try and home the machine and maybe the y-axis motors work, but the x-axis doesn't. There are a number of reasons why the machine might not be moving. Almost every problem you have on a CNC goes back to basically the machine underperforming. The controller, like 99% of the time, works just fine. The issue is that either the motors or the belts or the V-wheels, something in that chain of transmitting the power to move the machine just is failing. So the first one that people often miss is a stepper motor. So let me focus this in. So stepper motor rotates a pulley, and that pulley will pull a toothed belt around that pulley. So as you move, it rotates the pulley, or as the pulley rotates, it moves the belt. The first part of this drive chain that can potentially be at error is the whole pulley to stepper motor interface. So there are two set screws on this pulley, and if these are not tight, your pulley can slip on the stepper motor shaft. So the first place to look if your machine just isn't moving, even though you might hear the stepper motors clicking, is to make sure this isn't slipping. Sometimes these get loose, sometimes these need a drop of thread locker to keep them from backing out. If you've been using the machine for a while and all of a sudden it stops moving, check your pulleys. Here I've marked them in Sharpie just to make sure that they move in sync, and they don't. So when you tighten these set screws, make sure that, I don't know how well you can see this on the camera, but there is a flat on that stepper motor shaft. So one of your pulley set screws, make sure that's over that flat, because that'll help index this and key it and lock it in and make sure these two rotate synchronously. So pulley, stepper motor is probably the first place you should look. This happens a lot on the belt drive. So on the belt-driven axis, let me zoom out a little bit. This is a little close, a little too intimate. People will sometimes have the issue where this doesn't move as expected or it slips. That pulley for the stepper motor can sometimes be a little loose. So I would check there first if you're having any motion issues where either the commanded motion isn't being replicated or there's a little bit of slipping. Now, in addition to just the pulley itself being tight, you can also have the belt being a little too loose. So it's getting a little too cluttered. If your stepper motor has a belt just very loosely draped over it, there's no guarantee that the pulley teeth are actually going to engage this, or they might slip or jump. So make sure your belts are tight. Now, that will make sure your machine moves when this rotates. But there are some other things that could happen if this isn't perfectly tight, which is you might get backlash. So if you think about the stepper motor as pulling its way along, if you have a little bit of slack on one end, what's going to happen when the motor tries to move in this direction is it's going to start pulling up slack until it's tight, and then it'll start moving. So for that period of time, the machine is sort of just not going to be moving, and that's usually what causes, if you have round holes, to come out oval, because normally as you go around a hole, you travel in X, but if there's a little bit of backlash, as you move, the CNC thinks it's over here, and the stepper motor is always basically playing catch up. And once you reverse direction, it pulls up slack on the belt, and then it starts moving. So the X motion is always delayed, going in one direction or the other, or in Y, or perhaps in both, in which case you get sort of a diagonally oval hole. So making sure you have tight belts and a tight stepper pulley are sort of essential to making sure you get motion if the motor is turning, if the controller is working. So that is probably the first place to look. Now, I have intentionally ruined my machine by making a lot of these mistakes, and I'll show you a couple cuts that I did, showing some of the faults that might happen. And then I'll go through the process of correcting everything so that you guys can see sort of the before and after of what these machined cuts look like once you fix up these issues. So actually, let me pull up some of these, a little shot of the part that I machined earlier, so you can see what a bad cut looks like. And some of you might recognize some of these types of mistakes, because you might have seen them yourself. So I have a test cut program where I'm basically trying to machine a circle inside a square. And the first thing you'll notice is that on this cut, hold on, I gotta bring up my secondary display. Where is it? Transition, cool. And let's hide my face because that is not essential. Perfect. So here you'll see that for the first step down, the machine is for some reason cutting a little off. The layers don't line up. And so this was due to the fact that my belts were a little loose, and so there was a little bit of backlash. And not only do you have backlash in the motion, but when your machine is cutting and moving through material, what happens is the material pushes back on the spindle. And if your first layer, if you don't zero perfectly, can sometimes be a little shallower than the subsequent cuts. And because of that, you have less force, and so the spindle sort of settles in a location halfway between where the backlash wants it to be and where the spindle and the material is pushing the spindle to be. So sometimes you get different layer lines on the first cut, the first step down, because the cutting forces that the machine is soaking up are different as it cuts deeper. And then, let's see, another area where there's a problem is in the bottom left corner of this piece. You can see that this corner, it's not exactly square. As the cutter moves from right to left into this corner, it's straight, and all of a sudden when it changes directions, you can see it's, I don't know how well you can tell, but it sort of veers out to the left a little bit more before settling and cutting straight. And that's again because of the belts not being tight, there's a little backlash. So as the spindle starts pushing upwards through this material, the cutting forces are nudging the spindle over just a little more, stretching the belt a little bit, and then causing this cut not to be straight. So if you can straighten out your spindle, or straighten out your, tighten up your belts, you can straighten out the path that the spindle will take. So I'll go through the process of fixing these issues on my machine, and then we'll go over a couple more common problems that people run into. So let's go back to the wide camera view. Zoom in a little more. There we go. So I'm going to pull my machine forward, and I'll show you that I have this belt a little bit loose, and then I'll go through the process of just fixing that, and then we'll take it from there. So let me get my carriage out of the way. So this belt is a little loose. I don't know how well you can hear it, but it's not much of a rail slapper, whereas if I try a different belt, this belt is much tighter. You can hear it's smacking the Y rail pretty good. So the X-axis belt is a little loose. So I think I went over this in a previous episode, but basically the way I do this is I will just slide the belt through the anchor just up until the belt clip comes close enough to the end plate that a screw can catch onto the threads. You'll have to apply just a little bit of lateral force to stretch this taut before the threads will usually catch. But if this doesn't catch on the first try, just release a little more of the belt. And if this bottoms out on this plate before you've even started threading the end screw in, that means it's going to be too loose. So I'm just going to get this moderately tight. So I'll bring the anchor over just until this screw catches. And then you want to keep downward pressure on this end of the anchor, because as sort of this L shape, if it flips up, the belt's just going to unwind itself through the anchor. So just keep that the nose of it down as you tighten up this clip until the top edge is against the carriage plate. So let me try giving you a different view of this. I don't know how well this is going to work. This might be nausea-inducing, but we have belt clip with screw. Just make sure that top edge of the anchor is touching the carriage plate. Otherwise, the long end of it's going to lift up and let your belt out. Okay. No more shaky cam. So that is tensioning the belt to an appropriate point where it's now slapping the rail. And it shouldn't have allow any slippage or backlash. So let's talk about some other issues. Let me actually check the chat. When should we be doing maintenance on our machines? Do you wait until the belt's completely worn out? Do you recommend changing the belts once a year? So personally, I have never changed belts. As long as they're at an appropriate tension and you don't over tension them, they shouldn't really wear as long as you keep them clean. Sometimes they might fray if you really abuse them, if you get like aluminum chips that fall on top of it, and then the idler pulleys just roll over them and crunch them into the belts and start degrading the, I think they're neoprene with a Kevlar or steel cord through it. But they should be pretty reliable for the most part. I would say check seasonally with large temperature shifts, because aluminum and the belts are going to expand and contract at different rates. Seasonally is also a good time to maybe surface your wasteboard, because as the MDF expands and contracts through humidity changes, you can get differences, and as this expands or contracts, it might cause the frame to bow or sag in different ways. So big temperature shifts, seasonal changes, humidity shifts. If you're in a climate-controlled place, it's really just, unless you have a really bad machine crash, you probably shouldn't need to worry about checking these things. Let's see, that is focused out a little bit too far. Better. And then, so it's always good to just make sure everything's working before you run a project. So I'd say just go through, like, make sure everything's tight, just give it a little tap. Make sure there's no wobble in your spindle. There is in mine because I'm about to go over some of the causes of some misalignments in cuts. Yeah. So the other issues that can arise, we talked about why if your belt is loose, you might get backlash left and right. There are other conditions that would cause inaccuracy in your cut. So one of the other checks that I recommend is to just take your spindle and give it a little shake. If you hear any clicking or you see a lot of rattling, that means your V-wheels are loose. And this can cause a lot of issues just because the tip of the end mill is going to flutter back and forth as you cut. So that's going to introduce some errors, some potential layer lines as you step down deeper and deeper. The cut forces changes. It might kick out the spindle or pull it down. So loose V-wheels is a big issue as to why your cuts might not be accurate. And it can also sort of cause your zero to change because as you cut, if the forces tilt this upwards, you're going to get the offset in the y-axis is going to be different. So let's see. Tightening up V-wheels, the way I like to do this is, let me see if I can, how can I get you a good camera angle? I'm going to jog this over, and then I'm going to move the camera, and I'm going to switch just to my screen so I don't give you guys motion sickness. So I'm going to set up a camera with a close-up on the V-wheel, and people are dancing behind me, but you can't see them, unfortunately. Okay. So let's go back to the camera. So V-wheels. I have this one really loose. Let me see if I can change the ISO. Nope, that's locked. So right now I can rotate it freely with one finger. That is not good. I like to tighten these just until the point where if I jog the carriage back and forth, I can barely stop the wheel from spinning if I really pinch the wheel. Don't get your fingers caught under it as it rolls. But wrench to prevent the bolt from loosening. Your favorite pair of wrenches, I think this is a 10 mil if you have a actual proper spanner, and then rotate clockwise. So this eccentric nut, you want to bring this around so that it moves the axis of rotation of the wheel up and brings the wheel closer to the rail. If you rotate this counterclockwise, you can actually loosen the bolt holding this wheel on. So I always recommend going clockwise. So I'm going to bring this around to, I can still rotate the wheel freely, so I'm going to keep turning this. And about like even less than an eighth turn increments is usually fine to get this close enough. This is pretty close to where I want this to be. Oh, there's some horrible noise going on in the background. I think they're closing the garage door. So another, not even a 16th of a turn. All right, I can just barely spin that wheel. Before you do this, you should also wipe down your rails, make sure they're clean, take a little toothbrush, make sure there's no built-up dust on your V-wheels. And then this one is good. I'm going to quickly do the other one. Close enough, close, that's good. So here's why you don't want to just crank these eccentric nuts all the way up and just have the V-wheels crushed against the rails. If you do that, you run the risk of these V-wheels, when your machine is idle or not moving, just developing a flat spot. Because it is plastic, they will deform and take a set over time. So you want to keep them pressing against the rails, but not crushed without deforming the plastic. These should roll freely. Also, if you crush these wheels against the rails and they do build up a flat spot, it's going to cause a lot of resistance when you roll. So if you turn off the machine and you push the carriage back and forth, you might feel like little bumps periodically, like every 1.5 inches or so. That tells you that there's a periodic error, and it's likely linked to your V-wheels. And also, if you have the V-wheels really snug down on this rail, it's actually going to cause some friction. So normally let me turn off the machine. This should roll pretty freely. Like, I shouldn't have to work very hard to move it. At my machine at home, I have accidentally tightened these down way too much. And what happens is there's a lot of resistance when you push. And because of that, you can actually develop backlash from the belt even if this is properly tensioned. So I was trying to engrave some really tiny features, and so the machine needs to be able to move back and forth in really small increments really well. And if you have any backlash at all, that's going to ruin your engraving. So if your wheels are too tight, they sort of just lock down your spindle, your gantry, your carriage, and that can cause your features to come out just a little undersized or oval or just a little sloppy. So do not over tighten your V-wheels. I'm going to turn this back on and check the chat. So, a favorite way to clean my collet? Sure, let's go over that. So, collets are important to keep clean because that is where a lot of the precision of your spindle comes from. So, in this case, we have a Makita style collet or Carbide compact router collet, and that's close enough to in focus. There are tapered faces here that match the bore inside the spindle. And as you use the collet nut and the collet nut forces the collet into the shaft, and what that does is that action centers the router bit. And so if the interfacing surfaces aren't clean, that dust will push the collet off center, and you're going to get more runout. So if you want, just take a clean cloth, maybe a little isopropyl alcohol, wipe down these surfaces inside and out. Here, I usually just take an old toothbrush and brush this out, give it a little tap, get the dust out between changes. If you have a dust boot, a lot of times that suction is pulling dust up and then over into the hose, and so you get dust that gets packed into here. So even if you are still using a 1/4 inch collet, but you're changing tools, when you pull out the tool, there's usually a ring of dust in there, and if there's dust in there, there's probably dust everywhere else on there too. So I would just loosen the collet, give that a little tap, shake it out, give it a little quick wipe down, make sure there's no residue, and then reload everything. So that is my collet cleaning regimen. And let's see, what else do we have in chat? There's my 10mm wrench to adjust. I don't have a complete set of tools with this machine just because it is, I live with the tools that I have in the shop. At home I have a more complete set. just not here. So let's see, if you tighten the V-wheel too much, you continue to rotate them clockwise, or try again so as not to loosen the nut. So personally, there is a case where I would go counterclockwise to loosen this, but if you do that, if you do rotate the nut counterclockwise, make sure you hold the eccentric nut and then just give it another twist with the Allen key to reset that bolt head and make sure it's securely crushing the V-wheel. Okay, anything else? So dust boots, sometimes they do cause issues because when you have stiff bristles, which we are working on sourcing some really soft bristles that are easy to crush that won't apply resistance to your machine spindle or gantry. But if you have really stiff bristles that are hard to crush, as you're bringing the spindle down, the bristles are actually pushing the whole machine up and twisting it or torquing it. If you have a brush that's really crushed into the workpiece when you're trying to surface it or face it, it's going to twist or tweak the machine and give you some off-character cuts. So that's why you should try and just set your bristles so they're just lightly touching the surface at your desired depth of cut. We are getting some really soft bristles on the Sweepy that should work really well without causing these issues. But yeah, there's just dust collection, dust boots. That's one thing you have to make sure that you're also doing carefully and applying it in a way that's not interfering with your cut. Okay, so let's talk about what else is on the agenda, actually. So specific to, let me rehome the machine. Let me get this moving so I can get it out of the way. I'm still gonna have to wait for the bit setter because when you initialize this, you have to check the tool length. And let's just shoo this out of the way. Ooh, new chat. Will there be a Sweepy for the Nomad, pretty please? So with the new Nomad, I can't guarantee it yet, but the new architecture will be a lot friendlier for putting a dust boot on it, so that is definitely something we will look into. And even if we don't have it, I guarantee you it'll be a lot easier for you guys to rig something up to make it work with a dust boot. What else do I have? Let me jog this machine over and talk about something that people often don't consider when they're using the stock belt drive. So this is the stock belt-driven Z-axis that we currently have. This is the Z+. The Z+ has a hard stop. So there's a little stud here that prevents the carriage from overextending and coming off the linear rails. The belt-driven Z-axis does not have that. So when you have a spindle mounted here, you should always do a check to make sure that your router with the bit can reach the bottom surface of whatever it is you're cutting. Because if this plate comes off, if the bottom wheels come off a little bit, you can develop a little rattling. If they come off even more, like you're just swinging freely. And there is, unless you enable soft limits, there's no way to automatically stop this from happening. I believe we have it so that you can't jog too far past this, but if you're not careful, it is possible to have the bottom of the carriage plate, the V-wheels, come off the rails, and if so, that's another place where you can get wild movement in the spindle and lose your accuracy or the definition of the features you're trying to cut. With a lot of people using smaller tools, like let's say our 102, 101. So the regular 1/8" tooling we sell is pretty short. It's 1.5 inches. And if you insert that into a router, it's only going to stick out about yay far. And so to have a short end mill reach the wasteboard, or even if you don't have a wasteboard, the baseboard, this has to come down pretty darn far. So if you're cutting at the surface with a short tool, check to make sure you're not running off the rails. We have a lot of people who are like, hey, why does, like, at the bottom of my cut, there's, like, the layers don't seem to line up. I won't say all the time, but there's a large percentage of them where they don't realize that they're exceeding the travel limits of the stock belt drive. Let's see, I think that's all I wanted to talk about in that regard. You can adjust to a point where the spindle is in the mount, and that can help you get a lower cut. Or if you're using a really long tool and you're having trouble clearing your features, you can actually slide the router up. So that's one way you can sort of work around the restrictions of your 3.5-ish inches of Z travel to make the most of your 3+-ish inches of clearance. Okay, and then I think the last thing to talk about is really just tramming. So if your spindle isn't perfectly perpendicular to your wasteboard, you might get ridges in your cut. So if you cut a pocket or you're surfacing your wasteboard, you might feel little grooves or scallops, and that's because the router isn't dead perpendicular to this surface. So if you have a flat end mill that's crooked, one end is going to cut deeper than the other. So the way I like to fix this on the Z Plus or the HDZ, which has the spindle is mounted to a plate, that makes it easier to just, if you loosen 4 screws and then you just set this straight. There are tramming tools you can buy that cost like $100, which is more than I like to spend. So usually what I do is I'll just take a piece of wood with 2 1/4-inch holes drilled in it, stick an end mill in here, clamp that piece of wood on that side, stick an end mill or a pin on the other side. Let me see if I have one here. I don't think I do. But basically, you can even take like a coat hanger and just bend it from from the spindle nose to the table and just spin it. You're looking for a conical swept area to tell you which side of that swept area is closer to the table or not. So if it's low on one side, that means your spindle is crooked this way. In the about the x-axis, so in this direction of rotation, you can loosen 3 of the screws on either side and just sort of tweak the whole rail forward or back to help level out the spindle in this direction, and then lock that in. And then my preferred way of tramming it in this direction, so about the y-axis, is to just take 2 1, 2, 3 blocks and then just slowly lower the spindle mount until it's resting on here evenly. You might have to give it a little light tap with a rubber mallet. But once this is sitting flat to this, then that means your router will also be perpendicular to your wasteboard. You can surface your wasteboard first. If there are scallops, just make sure whatever block you have resting on it covers or spans multiple rows, so it sort of averages out to be level. You could also get a flat piece of glass and just put it on top and use that as a reference surface. A mirror will do just fine. So you've got options. All right, so that is more or less the basics of what I want to cover. So if you guys have any other questions, drop them in now. And in the meantime, I'm going to do a little cleanup here and take out the trash. And I will get to any questions once I clean this up. I did make a test cut here. Let's actually, I'll do another one of these cuts once I set this up, just so we can see if my fixes have addressed all the outstanding issues that I introduced for the sake of this demonstration. Do we need to tighten the Z-axis belt, and how? All right, let me pull out this prop again. Let me zoom in and focus. So the Z-axis belt is tightened by this screw. So you loosen this bolt and this nut just a little bit, enough for this little pulley to slide up and down just a little bit. You take the appropriate size Allen key, I think it's 3 millimeters, and just adjust this screw until it pushes down on this pulley and tensions the belt. This should be more than like a well-done steak. It should be strummable. It's not going to sound as loud or have the same twang as the X and Y belts because those are thicker, but it shouldn't flap around loosely. It should have a good bit of tension. Sort of like a very taut, thick rubber band. So that is the tension method for the belt drive. And once you have the right tension, make sure you tighten this bolt and this nut back up. Let's see. Can you set up a vertical or horizontal path for a pocket path instead of a round input instead of carbon motion? Carbide motion is our sending program. The specifics about the pocket direction, I think, let me switch to the screen. So in Carbide Create, there is not an option to set whether or not the toolpath moves in a raster direction back and forth, or sort of from the contours working in or out. I don't have Meshcam 8 on this, so I can't show you. Actually, do I? I think I showed this in the Meshcam episode. So when you make a pocket toolpath for this shape, it's going to work its way in or out, following the contours, basically. No, that's the wrong Meshcam. Let's try this one. So in Meshcam, there is a different option for a roughing toolpath where you can specifically set, it's called contour offset or parallel. And so contour offset works just like the Carbide Create toolpath, where if you're cutting a square, it'll cut smaller and smaller squares. And parallel, it'll do like sort of the laser raster style. It'll just go back and forth and advance either forward or backwards until it's cleared everything. In Carbide Create, you don't have any control over that. In something like Meshcam or Vectric or Fusion, you would. Let's see. Building a new CNC for the first time. Any tips for improving rigidity, belt, or lead screw? If you want more rigidity, definitely go for the Z Plus or the HDZ with the lead screw driven Z. It's a bear if you want to try and DIY a lead screw for the X and Y, so I wouldn't recommend it. I'd say just try the machine first. You can always mod it later, but we think the stock experience is good enough for like 95, 99% of people. But get a good Z-axis and go from there. The other thing to keep in mind is that the shorter the distance from the cutting tool to the mount and from the cutting tool to the rail, the less torque you have acting on the system. So people always like to keep their baseboard clean and have as much clearance as possible, but that means you have to lower your router down a ton, and so the moment arm between here and the rail is higher. So that's why I like to keep a supplementary wasteboard on top, just to elevate the piece a little. I can move the spindle up in the mount a little bit, and that actually reduces the tendency for this to want to buck or bob or twist about the X rail. Can I talk briefly about squaring the CNC? Sure. So tramming is specifically getting the spindle perpendicular to the wasteboard. Squaring is really about making sure that the X and Y are perpendicular to each other. And the way the frame is designed makes the MDF sort of an integral part of that process. Because if you think about these two Y-axis rails, there's not a lot keeping them from doing this, from turning the whole machine into a parallelogram. And by locking these two into the MDF, the skin tension of this MDF keeps the frame from doing this. So for people who want to forego the MDF, you have to make sure that you're not compromising the structural rigidity and squareness of the machine. What I like to do is I'll take a tape measure and I'll just shove it into one of these corners and measure the distance across to another reference point, so usually somewhere on the base frame on the front, and I'll measure corner to corner in the opposite direction, and I'll just sort of shift these back and forth a little bit. You might have to just like pull them this way a little bit or this way a little bit, and once you get that set, you lock in the MDF, and that'll hold that orientation and the squareness of the frame. Okay, let's see. Is there a hardwired pause option? There is not. Well, there is a feed hold pin on the controller, so you can wire in your own pause button. It acts just like the pause button in Carbide Motion, but that is something you would have to elect to do yourself. Let's see. All right, I'm going to keep setting up for just a test cut here. Keep dropping in questions if you have them, and hopefully we can get something cut out, and then I can release you all to go on with your days and have a fantastic weekend. All right. So this is all tight. I will clear my workspace so I don't crash into anything. Let's fire up Carbide Motion. Just going to clear all of this and just do a little quick check to make sure that everything is as it should be. So no rattling, no severe rocking back and forth. Everything seems tight. Belts are good. Let me set my 0. So I'm going to do a little square cut about here-ish. That's pretty tight. This piece of wood is just scrap, so there's a line going across it with the grain where it can very well split. So just making sure I have enough clamps on it so that it doesn't want to flap about. All right, so let's wrap it to about here, and then I will jog it in manually. Let's see. Any other questions? As far as cleaning products for end mills, it depends on what you're cutting. If you're cutting wood and you get like a really black tar or carbon-like buildup, I've heard a lot of good things about Simpligreen or even WD-40, but any sort of basic cleaners should work. If you're machining aluminum and you get sort of a gray coating of just aluminum dust, and if the aluminum itself is smeared on the end mill, if you drop it into a little bath of sodium hydroxide or lye, that will actually dissolve the aluminum in a couple minutes without damaging the carbide material of the end mill. So let's see. Yeah, oven cleaner I've heard works well, but I personally have only used, I think, Goof Off and Simply Green. If you have any other suggestions, feel free to drop them in the chat. All right, I can set my XYZ 0. I'm going to switch to a screen where you can partially see the CNC and I got to reconfigure my sources just because I am looking at the wrong display. Okay, let's do that. And then let me move the camera view because that is in our way. Okay, cool. So I've zeroed out the machine where I think it should be. And then I will run the test file that I have. It should take about a minute and a half. Basic cut test.nc. Start the job. It'll move to the front. It'll ask me about changing the tool, which I will not do because the correct tool is already loaded in. Set up my dust collection. I'm still going to use a clear, bristleless boot on the bottom just so you can see the cut better. Doesn't really matter. This is just to catch the particulates from floating away, the stuff you would breathe in. The bigger chips will still fly out, not a problem. And because I'm using the trying to focus here. Since I'm using the bit runner, I will power on this spindle and set the bit runner to auto. And then I guess I'll turn on the vacuum at the very last second. So assuming everything goes right, we should have a clean cut without any issues, none of the weird artifacts we saw before, and I'll see you on the other end. Okay, so let me just hit the vacuum one more time. Please hold. All right, so I'll just take this piece off the machine and just bring it in close to the camera. All the lines look straight. The circles are circular, as they should be. And we don't have any of the issues as before. So that is more or less mission accomplished. Let's go full screen on the camera. So I can try and focus this from afar. So straight lines, I'm using a downcut end mill. This is from our Amana, I think, 119 kit. Comes with a 1/4 inch, the V-bit, and the 1/8 inch downcut. So straight lines, clean cut, none of the issues we had in this one. So I have undone all the harm I've done to my machine intentionally, and that will conclude it for everything I've got to say here. We will stick around in the chat for a little while longer. Let me actually pull up the tool number for you guys. This is the 46200-K 1/8 inch downcut from Amana. It's part of a 3-tool kit that we sell here at Carbide. I'll pull it out of the collet so you guys can take a look at it. But I am ready to ride off into the sunset of the weekend, guys. If any of you guys have cool projects this weekend, let me know. Love to see what you guys are making. So 1/4" shank, 1/8" 2 flute, down cutting end mill. All right, well, thank you guys for being a fantastic audience as always. I'm gonna switch to sort of a waiting room screen, but we will be in the chat for a couple more minutes in case you have any last minute questions. As always, thanks for joining us for episode 13, and we'll see you guys for the next episode soon. Take care, guys.